Hi, welcome back to my channel, and this time I'll be discussing to you a part at which we will be able to plot a sketch of the locus. So first is, let's take a look into this word locus. When we say locus, it's actually set of points at which those points define the equation, something like that. So if your locus is x squared plus y squared equals 4, then technically that's a set of points in a circle with a center at the origin and a radius of 2, something like that. Now, there are a lot of criteria in order for us to sketch the locus. But so in this video, I'll be discussing to you first the first criteria, which is the domain and the range of a locus. So this is quite important in order for us to know if how wide or how long can your graph be able to reach. Range of locus. So the domain will tell you the expansion or how wide your graph can be able to reach with respect to your horizontal axis. Your range will be the opposite. It tells you how wide your graph can be able to get or can be able to reach with respect to the vertical axis. So let's say, for example, here I have the x in the y plane and I have a graph like this. So if the graph will be able to continue going there, then that means that the domain of the graph will still be defined somewhere here. And if it will be able to continue going there, then that still be the scope of your domain of the graph. Now, range on the other hand will tell you with respect to the vertical axis. So if the range will be here from here, going here and something like that, let's say that one, then this is the highest peak at which the range will be able to get, and this is the lowest at which the range will be able to get. Okay. Now, in order for us to identify graphs, this time we're not going to sketch graphs first because we're only focusing on the first part, which is the domain and the range. By the time that we'll be able to discuss other criteria, then that will be the time that we'll be able to sketch the graph. So I want you to subscribe down there. Click on the subscribe button to be updated for the next video. Okay, so let's focus first on the domain and the range of the locus. So how to solve for the domain? So here, number 1, solve for y in terms of x. Number 2, find all the possible values of the expression with respect to x at which it is defined. That's it. Okay, so let's consider this. For example, you have 3x plus 2y minus 5 equals 0. So in order for you to get the domain of this equation, you have to solve for y in terms of x according to the first rule. So 2y, I have here negative 3x plus 5. So my y becomes negative 3x plus 5 over 2. Now, The second rule tells you that you have to find all the possible values of the expression with respect to x at which this expression should be defined by those values. So consider let's consider the opposite instead. Let's find a value at which this expression will not be defined anymore. Can we be able to see a value on the set of real numbers at which this expression is not defined? If I substitute this by 0, I'll get 5 over 2. 5 over 2 is still a real number, so therefore when we use 0, the expression will still be defined. So can we find a certain value on the set of real numbers at which this expression will not be defined anymore? I guess not. If you will be able to find one, I'll give you 500 pesos. But technically, no. There's no such value in the real numbers at which this expression will never be defined. Therefore, all the values of the set of real numbers can satisfy this expression, which means that the domain, so let's denote this by dom, the domain of the locus of this expression, 3x plus 2y minus 5 equals 0, is equal to the set of real numbers. Yes, because all real numbers will be able to satisfy this expression that will never result to this expression as undefined. Get it? Okay. Okay, this time we'll be considering the how to get the range. So this is quite just the same. In how to get the range, you have to solve for the x in terms of y and find all the possible values of the expression with respect to y at which the expression is defined. So let's go back to the expression, to the locus 3x plus 2y minus 5 equals 0. So this time we'll be solving x in terms of y. So you have 3x equals 5 minus 2y. So you'll be able to get x equals 5 minus 2y over 3. So this will now be our expression that we have to check at which the value, this time, at which the value will be undefined. So can we be able to find a value in the set of real numbers at which this expression is not defined? Because if I substitute this by 0, you'll get 5 over 3, that's still defined. If you substitute this by, let's say, 2, this becomes 5 minus 4, so 1 over 3. 1/3 is still a real number, it's still defined. I think I will never be able to find the values in the real set at which this will be undefined. Therefore, my range, I shall be able to denote this by ran of 3x plus 2y minus 5 equals 0. The answer will also be the set of real numbers. Because all values, all elements of the set of real numbers will be able to define. Even if I use 1/2, 1/3, square root of 3, the expression will still be defined. Because it will still result to an element of the real number. Okay? Okay, so before we will be able to continue with a lot of examples regarding on how to solve for the domain and the range of a locus, we'll have to review first some properties of real numbers, because those are actually the things we have to look into on the expression by the time that we will be solving the domain and the range. So first is number 1. I'll use symbols instead to shorten the consumption of space. So for all AB in the set of real numbers, AB will also be an element of the real number set, provided that B is not 0. What does it tell you? when you solve for the domain and the range of a locus, when you get an expression, a rational expression, you have to look into the denominator, and you have to avoid that denominator will be equal to 0. Otherwise, that makes the expression undefined. Okay, number 2. For all a in the set of real numbers and an even integer, n, the nth root of a is an element of a real number if a is positive or 0. What does it mean? If you have a radical expression, you have to look into the index of the radicands. Example, you have cube root of x plus y, you have fourth root of x squared minus 1. So you have to look into the index of radicand. If you will be able to see that the index of radicand is an even integer, then you have to make sure that the expression inside the radical sign should be always positive or 0. So let's say, for example, these expressions here. You take a look into the index of radicand. The index of radicand is 3, which is odd integer, so you don't have to worry about that. Whether it's positive or negative, that will still be a set of real number. That will still be an element of the real number. This, on the other hand, if you take a look into the index of radicand, the index of radicand is 4. 4 is even. So therefore, you have to make sure that x squared minus 1 should be positive or 0. Otherwise, if you have this, then the expression will be undefined. Get it? Okay, so I think this so far the things that we have to consider when we are solving with the domain and the range. So these two is actually the most common thing that we have to look into. Okay, so let's consider an example here. So our example is the locus 3x squared minus 4y plus 5 equals 0. So how do we solve the domain and the range for that equation? So to solve for the domain, again, let's solve for y in terms of x. So let's isolate this. We have negative 4y equals negative 3x squared minus 5. Or we have y equals 3/4 x squared minus 5/4. So let's check again on this expression now. Can we be able to find a value in a set of real numbers at which this expression becomes undefined? If we use 0, this becomes 0. 5/4 is still a real number. It's still defined. So I guess no. We cannot find anymore a value in a set of real number that makes this expression undefined. So therefore, the domain of our expression 3x squared minus 4y plus 5 equals 0 is the set of real numbers. Because all elements of the set of real numbers will be able to satisfy this expression. Now let's solve for the range. So according to the rule, we have to solve x in terms of y. So we have 3x squared equals 4y minus 5. And this will becomes x squared equals 4y minus 5 over 3. which implies that x is equal to plus or minus the square root of 4y minus 5 over 3. So what we have reviewed earlier on some properties of a real number, we have to look into the index of radicand. So the index of radicand we can find in this expression is 2, which means it's even. Therefore, your 4y minus 5 over 3 shall be greater than or equal to 0. Okay? So let's solve for y. So this will imply that 4y shall be greater than or equal to 5. Or y shall be greater than or equal to 5 over 4. So what does it tell? Which means that your range shall only satisfy to all values of y which is greater than or equal to 4. So some elements of the real number will make the expression undefined. So let's pick a value, let's pick an element of the set of real numbers lesser than this. Let's pick 0 because it's smaller than this value. If we substitute here 0, you'll get square root of negative 5 over 3, which makes the expression undefined. So therefore, your range 3x squared minus 4y plus 5 equals 0 will only be from here. So 5 over 4 up to the positive infinity. So you cannot include anything, any values lesser than this. Let's try to pick 1. 1 because 1 is less than 5 over 4. So if we substitute 1 here, you'll get square root of negative 1/3, which is undefined. So this is only our range. So if you have a question, you can comment down there. Okay, so let's consider another example here. We have 3x squared y plus 2x plus 5 equals 0. So how do we solve for the domain and the range of this locus? So to solve for the domain, again, let's solve for y in terms of x. So solving for y in terms of x, we shall have 3x squared y equals negative 2x plus 5 minus 5. So this becomes y equals negative 2x minus 5 over 3x squared. So we have to check the expression with respect to x, at which that expression becomes undefined in order for us to know the value that makes the expression undefined, and we have to exclude that in our choice of getting the set of domain. Okay? So what makes this expression undefined? So remember what we have reviewed earlier, that when we have a rational expression, the denominator shall not be 0. So what makes it 0? When x equals 0. So if our x becomes 0, the entire denominator becomes 0. Therefore, our domain of 3x squared y plus 2x plus 5 equals 0 is the set of real numbers except the 0. Why? Because we don't have to exclude this 0. Remember that we use 0 here, it becomes 0 here, so the entire expression becomes undefined. Okay? So how to solve for the range? So let's solve for x in terms of y. So by solving x in terms of y, then we have to check the expression with respect to y. And let's have to evaluate that makes the expression undefined, so that those values that makes the expression undefined will be excluded in our set. Now, in this manner, like 3x squared y plus 2x plus 5 equals 0, how do we solve for x in that way? So, of course, we've done with our algebra class that we can do factoring and so on. In this case, we cannot use easily the factoring method because y is a variable, but we have to treat this as constant this time. So what I'm gonna do is I use the quadratic formula. this minus b plus or minus square root of b squared minus 4ac all over 2a. So this time I'll treat my a as 3y. Y in this case is a constant. My b is 2 and my c is 5. Hence, I'll have x equals minus b minus 2 plus or minus square root of b squared, so it becomes 4 minus 4a, and my c is 5 over 2a, which is 3y. So this becomes negative 2 plus or minus square root of 4 minus 60y all over 6y. So again, what we reviewed earlier is that number one, if our expression is a rational expression, then we have to evaluate at which the denominator should not be 0. Number two is, if we have a radical expression like this, a radical term, you have to check for the index of radicand. So the index here is 2. Hence, 2 is even. Hence, this expression shall be greater than or equal to 0. So, to evaluate that, I'll have 4 minus 60y should be greater than or equal to 0. So, 4 is greater than or equal to 60y, which implies that y is less than or equal to 1 over 15. Therefore, the range of our locus 3x squared y plus 2x plus 5 equals 0 is actually the set from the interval from the negative infinity up to here. So you have negative infinity to 1 over 15. But since, if you take a look to the expression here, you have to avoid y equals 0. Otherwise, this becomes undefined. Okay, so, but since 0 is found here, so you have to subtract that by the set containing 0. And that is now our range. Okay? Okay, so let's consider another example here. X squared y plus 2y plus 1 equals 0. So let's solve for the domain here. Again, to solve for the domain, we have to solve for y in terms of the x. So you have, I'll factor this y here in these two terms. I'll get y times x squared plus 2 equals negative 1, which implies that your y is equal to negative 1 over x squared plus 2. Now, this is a rational expression. So what we've reviewed earlier, we have to check that makes the denominator 0, so that we have to avoid that value to be included in our set of domain. Now, take a look. Even if I substitute these with the other values, this wouldn't make to 0, because no way we can solve for x in here, because this is already squared. So everything that we can input in this value, it will still be positive. So it wouldn't get the chance of getting the 0 as the denominator. Therefore, my domain here, domain of x squared y plus 2y plus 1 equals 0 is the set of real numbers. And how to get my range? So my range here is, I have to solve for x in terms of y. So I have x squared y equals negative 2y plus 1. So I'll have x squared equals negative 2y plus 1 over y. So I'll have x equals plus or minus 2y plus 1 over y. Which means that negative 2y plus 1, oh, sorry, it should be negative 1, should be negative 1, should be negative 1. So over y should be greater than or equal to 0. So I have to look into this. I have negative 2y minus 1 over y is greater than 0. So I multiply both sides of the inequality by y. So I'll have 2y greater than or equal to 0. And finally, I would have 2y less than or equal to negative 1. And hence, my y should be less than or equal to negative 1/2. And take note that okay, so let's check first. Our range here of x squared y plus 2y plus 1 equals 0 is now the interval from the negative infinity to the negative 1/2, because we have to consider all values less than negative 1/2. So I have negative infinity times negative 1/2. But we're not yet sure because the denominator here is y, so therefore we have to not consider the 0. So let's check. Is the 0 part of this interval? No. 0 is greater than negative 1/2. Therefore, this is already the final answer. That's it. Okay, so we're done with the part for the domain and the range of a locus. So this is actually a fragment of some criteria in order for us to sketch the graph of an equation easily. So moving forward, we will be going to discuss some criteria like the intercept, the asymptotes, and the symmetries of equation in order for us to graph easily. So for now, we'll stop this video first, and I want you to comment down there any questions, further clarifications, or any requests for your topics in mathematics. So also, I want you to subscribe if you haven't subscribed yet to this channel. So see you next time, and God bless.